All right, welcome to this special help session. This is specifically for the assignment, so I'm just going to go over a couple of things very quickly. So in the lab this week, we didn't get a chance to talk about multidimensional arrays, but they're very simple in terms of how they work. I'm not going to go into huge depth of them. I might in a later live stream, but I'm just going to show you the basics. So for multidimensional arrays, we can have two square brackets, one after each other. Now, this allows us to create a 2D matrix. Okay, so for example, I'm going to put 2 and 5 here, and I'm going to initialize it. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now this first box denotes the rows, and this second box denotes the columns. Okay, so we could see this as being one, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I wanted to access this element, I would just say A, 0, 1. So row 0, column 1. Okay, so the adding and, the indexes are the same, so 0, 1, 0, 1, 2, 3, 4. Okay, they still start at 0. Okay, to initialize one of these, we put each row in its own braces, and we put a comma between it, and then outside we also put these braces. If we had a 3-dimensional, then these would be braces, and we keep going along them lines. Okay, so in memory for this, I'll just quickly show you this. This doesn't really help with the assignment, but it's good to understand. These are all still in contiguous order. So we have ints that are 4 bytes. So we'd have 1, 2, 3, 4, 5, 6, and so on. However, these denote that we're looking at particular rows or columns. Okay, now the pointer arithmetic alternative is actually a little bit more complex, and I'll go through that in a later help session. But for now, this is good enough for us. Okay, and this is all we really need to know for the assignment in terms of two-dimensional arrays, in terms of this. So just a quick another example, A1. So if I had int x becomes A1, 2, I'm now talking about row 1, column 2. Okay, and so x would become 8. Okay, so in the assignment, we also have a 2-dimensional array. So when you go through the worked example, you'll see that you generate a table. Now, this table here has a bunch of components and then the total. Okay, we don't have the headings in our table. We don't care about that. Okay, so our table in terms of columns is going to be n components plus 1 for our total. Okay? However, our rows are going to be slightly different than this table. So because we've got to store the real and imaginary part, we can't store this in one box. So instead, we are going to store it like this. Is that 6? No. So instead, we're going to store it like this. So 40, 0, 0.3, 0, 12, 0. And that's for the R component. 0, negative 8.842, 0, 1.357, 12, and 0, and so on. Okay? So this is Z real, and this is Z imaginary. This here is I real, and this is I imaginary. And this one here is V real, and this one here is V imaginary. Okay? So we are going to end up with, let's find an empty space. And I'll reset the zoom. Let's find somewhere to write. Okay, so I'm just going to write here. So if we get the assignment sheet, I should have had that up. Assignment 1. Assignment 2, sorry. Give me 2 seconds. Okay. So if you have a look at the assignment, you'll see something that looks like this. Okay? So we have the number of components here, so each component, and then we have the total. Okay? And we have the impedance real, the impedance complex, the current real, the current complex, the voltage real, and the voltage complex. Okay? Or imaginary. So with this, if we had 2 components, our table would look something like this. If we had 3 components, our table would look something like this. Okay? 1 for each component, and then 1 for the total. Okay? So the number of columns is n plus 1. Okay? So, given that, we have a couple of things going on here. So I'm just going to get that step. I've already got it there. So on the assignment sheet, it says something like this. Program creates an array of pointers to double, and the array is of length 6. So we can see that the number of rows oops, is always 6. Okay. So we've got 6 rows here. So that's a constant. But this is not a constant. Now, in the lab this week, you will see when we want to create dynamic arrays, we need to use malloc, okay, or memory allocation. So in this case, what we're going to do, and as we saw in the lab, a pointer can point to an array. Okay, so what we're going to do here is I want to create just a array of pointers to doubles. So so something like double star A6 is going to be perfectly legal. So this is now an array of pointers. Okay. So what are we up to? Oops. Why did that close? Sorry, I just closed something. All right, so that's an array of pointers. So we've seen things like this before, except for we haven't had an array of pointers. So the only difference here is that with our array now, instead of storing values here, we're going to store pointers to stuff. Okay, obviously right now they're pointing to nothing. So we need some kind of way to set each one of these to a row of values, okay, and this many values. So there is a couple of ways we can do this, but because we need a dynamic array, we're going to do it this way. So using a for loop, so let's make I, and let's make a for loop. I equals 0, I less than 6, I plus plus. Okay. Just going to move that out of the way. So we'll need that guy in a second. I am now, for each one of these, going to allocate memory for an array. Okay? So I can do something like this. AI becomes malloc, and I'm not going to tell you what's in there. Okay, I'll leave that for you. Something in there to specify the amount of memory needed for this row, okay, for the number of columns. All right, I'm leaving that for you to solve. Okay, so here, what I have done is basically for every, I should do this a little later. For every row, I'm going to have a bunch of doubles. Okay, because this is a pointer to a double, and as we saw today, dot, 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 however big it is, as we saw, not today, in this week's lab, when we use malloc, we can create an array of the type. Oops. Yeah, we can say that. That's what I'll do. Actually, I won't do that. I'll do this instead. Okay. And then I'm just going to copy and paste these. Damn it, I'm running out of room. Okay, so whoops, what happened to my pen? Oh, I need to merge the layers. Merge this one. All right, so now we end up with 6 because we need 6 rows. Of pointers to these arrays of doubles that have been dynamically allocated using malloc. Okay, so this is all good and it creates what we wanted. Okay, so we've got 6 rows that we can select from. 1, 2, 3, 4, 5, 6. And inside each of these rows, we have n+1 values. Okay. So if there was 5 components, then this is what it'd look like. If there's 4 components, it looks something like this. Okay. So I'm just going to make this a little bit simpler and just draw it like this, just to make it a little easier to visualize, if it makes it easier. Oops. Now, one thing to remember, even though I've drawn it this way, this isn't quite correct. So I'm just drawing it this way so that you can see how it relates in terms of a matrix. And I need one more. Okay, so you can see here that we end up with a 2-dimensional matrix. However, you've got to remember that these aren't contiguous after each other, okay, like before. However, because we've got pointers, we can actually use array notation exactly as we saw before with the 2-dimensional arrays. I won't go into how this works in this help session right now. I might go over it a little bit later. But the second part says to say, store the source voltage in row 5, N equals source voltage. Okay, and then we've got result 5, N. Oops, that should be a 4. Becomes 0. So with this 4 is referring to 0, 1, 2, 3, 4. So it's referring to this. And the n is actually referring to this, we're on 4, this one here, because that is the last thing in our array. Okay? And 5n is going to be this one, so it leads us down here, and n is the last thing in our array. So this will store whatever's got source voltage and 0. Obviously this will be a number, but I'm just going to write that there. Okay? So this whole array notation still works. All right? And so throughout your assignment, you don't need to use pointer arithmetics for the 2D array. Okay? It's only the 1D array, which you will see is things like components and values. These are both one-dimensional, and they're just using malloc, as we saw in the lab this week. And the 2D is result. Okay? And the 2D, you do not need to do pointer arithmetic. Okay? So what I'm going to do now is just check with the people that are here that that makes sense, that I haven't accidentally made a mistake or anything like that. So just, if you're in the chat and that makes sense, just say yes, and then I'll explain what we're going to do. So as I said, I'm assuming that you've understood the stuff from the labs and lectures so far. I'm not going to go into that in this little thing. Okay, so we create our array of doubles, and it actually tells you what to do. And then we need to create a for loop so that we allocate memory for every column. Okay. All right, so what I'm going to do now is, if you're still watching, have a read at the chat as I'm going to create another help session. And I'm just going to close this video so that I can post it independently on LMS. Okay. So what I'll do, stop that.